Leaf springs manufacturing is a complex process vital to the automotive industry. Our comprehensive guide dives into the methods, materials, and quality controls involved in producing these essential components. A leaf spring is a simple form of spring primarily used in the suspension systems of wheeled vehicles. It is sometimes referred to as a laminated or carriage spring, or by other names like elliptical spring, semi-elliptical spring, or cart spring. Leaf springs are composed of layers of steel of varying sizes sandwiched one upon the other. These layers are usually cut into rectangular sections, held together with metal clips at either end and a large bolt through the center. The entire assembly is mounted to the axle using large U-bolts, securing the suspension in place. Leaf springs serve several vital functions within a vehicle's suspension system. Positioned at the back of the engine, leaf springs support the entire weight of the automobile, aligning the tires with the road, regardless of speed. By keeping the tires aligned with the road, leaf springs ensure proper grip, which is essential for safe driving. The unique construction of leaf springs allows them to flex under pressure but return to their original shape, providing comfort and control while the vehicle is in motion. Despite being one of the oldest types of springs, leaf springs have remained relevant, particularly in heavy-duty vehicles like SUVs, trucks, and vans, where their robust design is highly beneficial. In the assembly of leaf springs for vehicles, several components play vital roles. The main leaf is the primary structure that bears most of the load, while the thinner helper leaves add support and flexibility. A center bolt fastens the leaves together, and clips prevent them from shifting, ensuring stable performance. Lastly, bushings, made of materials like rubber, cushion the ends of the leaves, and shackle plates connect the springs to the vehicle frame, enhancing ride quality and handling. This process begins with design and prototyping. This step utilizes computer-aided design, CAD, to create and optimize leaf spring designs digitally. Rapid prototyping techniques are also employed to swiftly generate physical or digital models, facilitating efficient testing and refinement prior to final production. Leaf springs are commonly made from spring steel, a high-carbon steel alloy known for its strength and hardness. It can come in bars or coils and is shaped using machines. For parabolic springs, the steel varies in thickness throughout the leaf. The main leaf ends form eyes for attachment purposes and can be reinforced with metal. Subsequent leaves are shaped to match the main ones. To enhance its qualities, spring steel undergoes heat treatment. It's first heated and then rapidly cooled in a process called quenching, which bolsters durability. Next, it's reheated to a lower temperature and cooled slowly, a process called tempering, which enhances its flexibility and resilience. Heat treatment is essential for enhancing the strength of materials. It involves controlled heating and cooling processes applied to a material, such as metals, to alter its microstructure and properties. Annealing is a heat treatment process used to relieve stress in materials such as metals or glass. It involves heating the material to a specific temperature and then slowly cooling it down, often in a controlled environment. During annealing, internal stresses within the material are reduced or eliminated, resulting in improved mechanical properties and increased durability. The process allows for the redistribution of atoms, reducing defects and restoring uniformity. Quality control and testing in leaf springs manufacturing are essential to ensure the product's durability, performance, and safety. First, the main processes involve non-destructive testing, NDT. Detect surface defects using magnetic fields, revealing potential issues in the spring's integrity. Uses high-frequency sound waves to identify hidden internal defects like cracks or flaws. In leaf springs manufacturing, various testing methods ensure the products meet the required standards. Static load testing checks the spring's ability to bear weight, while dynamic load testing assesses performance under normal use. Deflection measurement confirms that the spring's bending aligns with design specifications, and fatigue testing evaluates its long-term resilience.